When AMDIS first comes on, what you'll see is an empty screen. In order to analyze a data file, you first have to bring up the data file. So you go to File, Open, and then you use this sort of normal file selection to go and find the file that you're looking for. Now you'll notice down here that a whole series of instruments are supported. These are the different file types that you find. We happen to be looking in this particular case for an Agilent ChemStation data file. The file that we're looking for is over here in the tutorial, and you see that these files are marked, and only those files that satisfy this criterion are brought up. So I'm going to bring up this file and I'm going to open it. And when I do that, I bring up a window up here that has the TIC and typically some random scan someplace in the data file. It's just exactly that, a scan. I can go any place on here. I can look at what an individual scan looks like. Any place along here. I can click the forward arrow and I can scan through that. But of course what I really want to do is I want to analyze this data file using AMDIS. I don't want to just look at it. To do that we need to set up two things. The first of them is the location of our library. That's under Settings. And the Settings window will come up and it will have in it a whole series of possible settings. There'll be identification, the instrument, the deconvolution, the library, some QA/QC, and some scan sets. We're going to focus initially only on the deconvolution and the library. The instrument you will see is defaults back to the instrument that we had previously chosen. We're going to come back to the identification. We're going to start out with the simplest thing, which is a simple identification. We're going to look for a minimum match factor of 60, and then we're going to look for a library. Now the one thing that we have to have besides a data file to do an analysis is we have to have a library. So we select a library. The program will automatically bring up another file selection box. And that file selection box will have all of the possible libraries that the program can find. AMDIS libraries have an ending of .msl. So we're going to select this one, PEST plus MSL. We're going to open it. And we have the option of viewing it at this point. We can view that library. And it's a small library. It's just a little demonstration library. There's several things about it that you can see right away. One is that we've got a number of ways of sorting it. We can sort it by ID, by name. And you see it's brought these things up alphabetically by name, alphabetically. We can sort it by retention index, and we get all of the retention indices, and we have a series of compounds for which we don't have retention indices. And we'll see, we'll come back and talk about that in more detail later. We can also sort by ID, and you see here we have some of these compounds which have a normal CAS number and some which don't. AMDIS doesn't require that you have a CAS number. It's probably better if you do, but it's not required. So we've got a library, and we've sort of looked at that library. In this case, we need nothing else. We don't need anything about the calibration data. We don't need anything about the standards, the internal library. We're just going to identify anything in the data file that matches up to those things in the target compound library when they have a match factor of greater than 60 on the basis of 100. The program perceives that you've changed things. you can either say yes here to analyze it, or you can say no, which I typically do, and then go up here and say, okay, everything's ready. You might want to check it again, and you say run. The program will bring up a little time delay box, and when it's all done, it will show you what it's found. And it shows you it found 16 targets and 312 components. The targets are indicated by these T's here, which there's 16, and the components are these small triangles. There's a lot more of those. We can examine these things in greater detail in several ways. There is a window down here that blows up each individual one of these hits, or we can blow them up ourselves. So I'll go to one of these things. Let's just say, just for convenience, I'll go to this one right here. I'll blow up. I'll just drag and drop this thing. And I'll say, oh dear me, where is this? I don't see much of a peak. Well, I can see what the program, I can right click here, and I can tell the program to show the component. And it's this very, very small thing here, stretched out over this much space. I can blow it up a little bit more, and you can see there's a peak, but it's a very, very weak peak. Here's what the spectrum looks like, and you can see that there's a lot of other stuff there. As a matter of fact, only 9% of the total ion current at the center of this is associated with the component. The rest of it is associated with this what appears to be a hydrocarbon that's tailing off here. So this is a very low component buried inside this. But we've been able to find it. So we've been able to go here, open a file. We found the file, if you'll remember. Go into our Analyze and our Settings. Get a library, and everything that had an identification factor, match factor greater than 60, we kept. And that's all there is to it.